2.3c, this is systems of equations with special cases. So we looked at systems of equations, special cases when we were graphing. It's the same concept where you can get two lines that intersect and there's one solution, and that's the xy coordinate that we find when we've been solving these systems. Another type of solution you'll see is parallel lines. That is no solution. So when they do not ever intersect, you'll never get a coordinate for it. There will be no solution. You'll see this algebraically when both variables are eliminated. And then you end up with a statement that's not true. So you're going to end up with something like 0 equals -3. That's obviously not true. So if you get no variable, so you don't end up with x equals or y equals at the end, you end up with a number equals a different number, that means there's no solution. The other possibility is infinite solutions, and that is when the line is the same. It's the same line, the equation is just in a different format, so it doesn't look the same. You will end up with all variables and constants eliminated and a statement that's true. So 0 equals 0, or 6 equals 6, or 12 equals 12. This will be a true statement. That means it's the same line, and any point on that line is a solution. So there are infinite solutions because there's an infinite number of points on a line. So solving these algebraically, you need to be able to identify how many solutions are there. One solution, no solution, or infinite solutions. If there is one solution, you'll need to tell me what it is. So that's listing the ordered pair like we've been doing so far. So for each of these, we're going to figure out, should we use substitution or elimination, and figure out what the solution is, or identify if there's infinite or no solution. So let's look at number 1. Immediately looking at number 1, I can see the easiest way to solve this is elimination because I have opposites. So I add these equations together. Negative 10x plus 10x cancels out. That's 0. Negative 9y and positive 9y also cancels out. That's 0. And then negative 10 and 10 is 0. So I end up with a statement that says 0 equals 0. That means there are infinite solutions. That means that those equations are the same line. Number 2, negative x minus 8y equals 2, and x minus 6y equals negative 16. Again, I think elimination is the best method here because I can see that the x's are going to cancel out. We have negative 1x and 1x, so these cancel out. Adding the rest of the equation together, negative 14y equals negative 14. Now I just solve, and y equals 1. So if y equals 1, then I can plug this into the equation and solve for x. So x minus 6 times 1 equals negative 16. X minus 6 equals negative 16. Add 6. And x equals negative 10. So my solution, there is one solution, and the solution is negative 10, 1. So all of the assignments we've done so far have been one solution answers. In this assignment, you'll be getting different ones, and you'll need to identify what the solution is if there is one, or if there are infinite or no solutions. Number 3. This is another one where elimination is the best way to go. because I have variables that are going to cancel out if I add these together. Negative 9x and positive 9x cancel out. Negative 7y and positive 7y cancel out. Then I have negative 27 plus 20. So this equals negative 7. So I end up with a statement that says that 0 equals negative 7. 0 actually does not equal negative 7. So there is no solution. That means these are parallel lines and they will never intersect. Number 4, I think that elimination is the best method, but I'm going to have to change one of the equations so that something cancels out. So I'm going to multiply this first equation by negative 1. So I end up with negative 10x plus 9y equals positive 10. So now I can cross this one out, and I'm going to add these two together. X cancels out, y cancels out, so these are both 0, equals positive 6, which is not true. These are, again, parallel lines will never intersect, so there is no solution. Number 5, I have one variable that's isolated, so I can use substitution. So when you're doing substitution, and those of you that are still in substitution AJ1 or AJ2 can pay attention to this one, because some of you are really struggling with substitution. You're looking for the isolated variable. That's y. Y is by itself on one side of the equal sign. Then you're going to find y in the other equation and substitute it in. So I'm going to put parentheses around y, because that's where I'm going to put my substitution. And what is being substituted for y is x minus 1. So now I'll rewrite the first equation substituting x minus 1 for y. 5x minus 5 times x minus 1 equals 5. Then I need to distribute. Negative 5x plus 5 equals 5. Combine like terms. These cancel out. 5 and negative 5. So I'm left with just 5 equals 5, which is a true statement. That means there are infinite solutions. These are the same line. Number 6. Since both these equations are in standard form, I think I'll use elimination again, but I need some opposites so that one of the variables cancels out. If I multiply the top equation by negative 2, that will give me a positive 18x, which would help me eliminate x. So I'm going to multiply by negative 2. This is going to be positive 18x minus 14y equals negative 54. Now I can cross this one out and add these two together. 18x cancels out. 8 plus negative 14 is negative 6y equals negative 54. Divide by negative 6. Y equals positive 9. Now I can plug in y equals 9 to either one of these equations. So I'm going to use the second one. Negative 18x plus 8 times 9 equals 0. So negative 18x plus 72 equals 0. Subtract 72. Negative 18x equals 72. Divide by negative 18. X equals 4. So there is one solution. And that solution is 4, 9. Two more examples. I have two equations again. Both are in standard form, so I want to use elimination, but I need to multiply one of them so that one variable will eliminate. So if I multiply the second equation by negative 2, that will give me positive 12x. So 12x plus 6y equals positive 30. Now I'll cross this one out, and I'm just going to rewrite this one down here. Negative 12x minus 6y equals negative 28. The x's cancel out and the y's cancel out, so I have 0 on the left side of the equal sign. 30 plus negative 28 is 2. 0 does not equal 2, so there is no solution. Number 8, we'll use elimination again. However, I'm going to have to multiply both of these equations because they don't have a common variable that will cancel out. So I will have to multiply the top one by positive 6 and the bottom one by negative 5, or I could do negative 6 and positive 5, but remember one of them has to be negative to cancel out. So I'll multiply this top one by 6, which gives me 30x plus 30y equals negative 120. And I'll multiply the second equation by negative 5 to give me negative 30x. Negative 30x minus 30y, and then negative 5 times negative 24 is positive 120. So these all cancel out. So I end up with 0 equals 0, which means there are infinite solutions. So on your practice today, tell me whether it's one solution, infinite solutions, or no solution. And if it's one, you have to tell me what the coordinates are of that one solution.